All right, so I guess from the top here, rational numbers, fancy way of saying we're working with fractions. So like a rational technically is defined as a over b. Like say 4 over 5, that's a fraction. Makes sense. 0.7 is also technically a rational number. But it's not written as a fraction though. Ta-da! Now it is. Almost everything's a rational number. Usually we don't write it as 7 over 1 though, or 0.7 over 1. Usually we times everything like by 10 and make it 7 over 10. That makes sense? But like almost everything is a rational number. If I gave you the number -4, there, look, it's over 1. It's a fraction. There are very few exceptions for how this works. Things that are not rational numbers are irrational numbers. Pi is considered to be irrational. You guys heard that before? Like pi is 3.14 for forever. The square root of 3 is like 1.7 blah, 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 blah. You can't write that as a fraction. Someone might argue you could write it as that over 1, but we say that as a count, I guess. So our goal is to deal with fractions. First thing you need to know about fractions then, the bottom of a fraction can never be 0. You guys aware of that rule? You've heard that before? Like you can't take 3 and divide by 0. It's not permissible, I guess. I guess the rationale to this is dividing by is like putting things into groups. You can't have 3 groups of 0. Because then you don't have anybody in a group. Does that make sense? Technically, you can have 0 groups of 3. Apparently that has been deemed permissible, but this one's not. So. In terms of terminology I want to use, the top of a fraction is the numerator, the bottom is the denominator. Chances are you guys have heard this though, right? I always like to start like right at the beginning though, so sorry if this is review. Here are some irrationals. 2 pi is irrational. Sine of 37, by the way, if you type that in your calculator, it's irrational. But like these guys right here, these first ones are rational. By the way, do you guys know how to turn this into a fraction in your calculator? Do you guys know how to make a decimal number a fraction? Yep. Okay, so like type in math, frac, and then type in like 2.8, but you're probably gonna have to put in a lot of 8s. Actually, no, you gotta go 2.8 first, and then go math fraction. And hopefully that'll make it a fraction for you. You guys ever seen that before? Okay, let me do that again then. 0.75. I happen to know off the top of my head 0.75 is 3 over 4. But in case you didn't, type in the number, go math. The first one will convert it to a fraction. It's 3 over 4. That was useful. You guys ever seen that? Okay, cool. At least now you have.
It automatically puts it in lowest.
It will lowest terms it for you, yeah. Okay. My goal today then is just to do some introductory stuff on how to deal with fractions. So let me give you an example. If I gave you 9 over 12, at some point in your lives you probably learned how to reduce, is the word you'd probably have talked about, reduce. So like 9 would become 3 and 12 would become 4. Here's the question though, why? Why was that allowed? Well, in a way what you're doing is you're dividing the top of the fraction by 3, and you're dividing the bottom of the fraction by 3. 9 divided by 3 is 3, 12 divided by 3 is 4. Does that make sense? The reason why that's allowed, by the way, is that, you know how like you can multiply by 3 over 3? Well, that's like multiplying by 1. You can also divide by 3 over 3, because that's still dividing by 1. So then, like, again, 9 divided by 3 is 3, 12 divided by 3 is 4. Does that make sense? Okay. That's with numbers. We're not going to throw letters in. Yay! So let's try the first one. What does m to the 3 really mean? It means there's 3 of them. It means that you have m times by m times by m, and then you have 2. What does m squared mean? There's 2 of them. So you have m times m, and then you have t 4 times. 1, 2, 3, 4. basic rules then, if you have something on the top of a fraction, on the bottom of the fraction, it can, yeah. So this m right here cancels that m, this m cancels that m, this t cancels that t, and I'm done canceling. So what you're left with is m on the top and t to the third on the bottom. That makes sense so far? Okay, here's another way I'd like you guys to know how to write this. Has ever seen that before? Or is that new? Okay. If you ever have something on the bottom of a fraction to an exponent, another way of writing it is to no longer have the fraction, but to write the same exponent but with a negative sign. So see how this t3 was on the bottom of the fraction? Get rid of the fraction and write it with a negative 3. And that actually is equivalent to the same thing. So like, for example, 1 over x squared is known as x to the minus 2. That'll come up occasionally. So, you know, if you left it at this, by the way, I wouldn't mark you wrong, though, just so you're aware. But if you ever see something like this, this actually in a sneaky way implies a fraction. Okay, let's try some other ones then. 18x to the 4. Well, that means you have 18, and you have x, and you have x, and you have x, and you have x. And by the way, I'm only going to do it like this one more time, because it's kind of ridiculous to write out every single x, right? This one right here means you have 36. And you have x, and x, and x, and x, and keep going. There we go. That makes sense so far? So that one goes, that one goes, that one goes, that one goes. How many x's are left? How many x's are left?
3.
3. Okay, good. So you could say that on the bottom of your fraction, you have x to the 3. And then 18 and 36, those can actually reduce, right? They both are divisible by 18. So if you like divide this guy by 18 and divide this guy by 18, you get a 1 and you get a 2.
So like, you just take the 1 away, it's just 2x.
You could then make it like 1/2 and call it x to the minus 3. And actually that leads me into the new rule I want to show you, which I think you've learned, but I don't know. I need to learn more about what you learned in junior high. What is 4 minus 7? Negative 3. You guys ever seen that before? This 4, subtract that 7, is where that negative 3 comes from. You guys ever seen that before? You might have. I don't know. I think it's a grade 9 or 10 skill. Either of these two answers right here would have been valid. Shelby?
Okay, but what if the 7's on top of the fraction, and then we reduce it, and we want to make it so it's like 1/2 instead of 1/2? Would the integer still be negative?
The integer in front here is not negative.
Not the integer, the exponent.
The exponent, like, let's say, are you saying it was like a 7 over a 4?
Yeah.
Okay, so in that case, then it would just be x to the 3. Because 7 minus 4 would be 3. But in this case, because the 7's on the bottom, it's a minus 3. Does that work? Oh yeah, let's try the next one. Because the next one adds a new twist, obviously. Whoa, what am I doing? I guess I can't go back further than that. Yeah.
What was that? Did you just slam that?
Okay. What's different about this guy right here? Good, that's the word I was hoping to hear. There's a binomial on the top. A common mistake kids will make when dealing with fractions is something like this. Let me just give you an example with numbers. 4 plus 3 over 3. And they'll say, the answer's 4. But that's not how it works. Does that make sense? The answer was actually 7 over 3. And 7 over 3 is not the same as 4. You can't, like, half cancel something. Does that make sense? And so a common mistake kids will make here is they'll say, hey, look, here's a 3 and here's a 6, and I'll make that a 1 and a 2. But you can't do that. That makes sense? So we have to use a different skill. The binomial can be factored. 3y minus 9y squared, you can factor this. So what can you factor out of that? Good, yeah, 3y. If you factor a 3y out of a 3y, you're left with 1. And if you factor the 3y out of the 9y squared, actually you're left with 3y, yeah. And just double check your work, right? Like 3y times 1 is 3y. 3 times 3 is 9, and y times y is y squared. Okay. In terms of canceling, monomials can cancel monomials. Binomials can cancel binomials, but not one of each. Does that make sense? What we have here then is this guy right here is a binomial. Unless for some reason I have a binomial exactly like it on the bottom, it can't cancel. But right here I have a monomial of 3y, and I have a monomial of 6y cubed. Those can cancel if I do it properly. So 3 and 6 can cancel, right? You're left with a 2 on the bottom. The y on the top and the 3 y's on the bottom, those can cancel. How many y's are you left with? 2 on the bottom. That makes sense? So you could write it like this if you want. And then you have to leave the 1 minus 3y up top though, because it cannot cancel. It's a binomial. Does that make sense? So this one canceled, and then that one kind of canceled as well. We've actually kind of been doing this already with the quadratic formula. I'm just going to do a brief aside here. Let's say your quadratic formula gave you 2 plus or minus 4 root 3 all over 2, which was actually the answer to one of your assignment questions. The reason why you can do some canceling here is that these guys right here have a number in common. They have a 2 in common. And what we're essentially doing is we're factoring out a 2, leaving you with a 1 plus 2 root 3 all over 2. Does that make sense how this guy has a 2 and this guy has a 2? Factor out the 2, and then this 2 and this 2 can cancel. Does that make sense? Let me try just one more example here. Let's say you ended up with 3 plus or minus root 72 all over 6. How can we simplify this? Can I just take this 6 and that 3? Can I just divide those two guys by each other at this point? The answer is no, I can't. Because the top thing right here has a plus or minus sign in between. So what do I got to do first? The 72. Work on the 72. What does 72 equal? That'll work. You can actually do better than that though. So 9 works. 16. 25. 36. 36. Does that make sense? So then you can write it as 3 plus or minus 6 root 2 all over 6. I showed you guys this trick a little while ago, but I want to show you officially what you're doing here. The top here is a binomial. You have 2 terms separated by plus and minus signs. But on the top, see how 3 and 6 have a number in common? You can then factor out the 3, and it would leave you with 1 plus or minus 2 root 2 all over 6. Because like 3 times 1 is the 3, and 3 times this really ugly looking 2 is the other 6. Makes sense? This little bit right here, it's stuck. But this 3 and this 6 right here, those can cancel. That's valid. So then that becomes a 2, and that just goes away. And so my final answer is 1 plus or minus 2 root 2 over 2. Common mistake. Kids would look at this and say, hey, look, there's a 2 and a 2. I can cancel those. You can't. Because this 2 is part of a binomial on the top. Does that make sense? Cool. Okay, let's go back to wherever I got sidetracked. Let's try this one right here. Can I just go 8 and 4? There's a 2 there. 6 and 3. There's a 2 there. Yeah. You know, like that wait for the opportune moment?
Yeah.
That's not the opportune moment. This is not the right spot to do that. We can only cancel binomials with binomials and monomials with monomials. So if I want to do some canceling, I got to factor. So anything in common. By the way, I think there's a typo here. I think this should be a 3. Can we make it a 3? I think I do that every year. Forget to change it. What's in common on the top between 6 and 8? Yeah, good. 2 and m. Leaves you with 3m minus 4. And then on the bottom, what's in common down here then? Actually, more than just a single m. You actually have 2 m's in both of them, so you could go m squared, and it would leave you with 3m minus 4. Yeah. There's a purpose here, right? This 3m minus 4 and this 3m minus 4 are the same. Those can cancel. They are a binomial, and the binomial, by the way, is the exact same. If one of them was a plus, they can't cancel. If this was a 5, doesn't count. Like, it has to be literally the exact same thing, but they do cancel. And then one more thing. You have an m on the top, but 2 on the bottom. So you could say this is 2 over m, because like this one cancels with that one. Or another valid way of putting it is you could say that it's 2m to the minus 1, because you had 1m on top, and then you're subtracting 2 on the bottom. So then 1 minus 2 is minus 1. But I'd accept either of these. That make sense? Let's see what else I've got here. Whew, today's going to be a long day. Okay. Okay, here's a slide that basically talks about what I was saying here. If you have, like, say, 3 plus 6 over 3, you cannot cancel those 3's. It's the same thing with these x squareds right here. Don't do that. Again, canceling is totally valid when you're doing fractions, but wait for the opportune moment. And this was not it. Why don't we just try one more here, and then... Well, let's do the bottom one. So I want to show you a trick on the bottom one before we take a breaker. Can you do anything with the top? Can I cancel this one and that one? No, they're part of binomials. Oh, what am I doing here? But you know how the bottom right here is a x squared minus 1? I can factor that. What does it factor to? X plus 1 and x minus 1. That makes sense. It's a difference of squares, right? Because you can square root x, you can square root 1. You guys remember difference of squares? Okay. Can I cancel anything? Are any of those binomials the exact same as each other? This is 1 minus x. That's x minus 1. Are those the exact same? They're not. Okay, but I actually have a point behind this one here because there's a trick you can play. I like to call this my minus 1 trick. I'm going to multiply by minus 1 over minus 1. Why is that valid? Because I'm just multiplying by 1. I'm doing it on top and bottom, right? Here's what I'm going to do, though. I'm only going to multiply that minus 1 into the top term. I'm going to FOIL it, like distribute it. So like if I do minus 1 times 1, you'll get minus 1. And if I do minus 1 times minus x, you'll get positive x. Does that make sense? Basically what I'm doing on the top here is I'm flipping the signs around. So rather than it being a plus 1, it's a minus 1, and rather than it being a minus x, it's a plus x. To use the minus 1 trick properly, though, do not distribute the minus 1 on the bottom. Just throw it up front. Because I don't want to distribute it. If I distribute that minus 1, it will cause this guy right here to no longer be x minus 1 anymore. And the point I want you guys to see here is, see how I have the exact same thing on the top now as I had on the bottom? Now it can cancel. So there's a trick you can play if they're close. If they're opposites, times by minus 1 over minus 1, it'll flip the top one to be the same as the bottom one. The only difference, though, is you have to throw a minus 1 on the bottom. That's all. So then your final answer is 1 over minus 1 with x plus 1. You know when you cancel the top, though, you actually have to put a number there. You have to put like the number 1 on top when you cancel it. Okay. Pardon me?
On the bottom.
Right here?
Yeah. Is it x plus 1?
Yeah, one is x plus 1, one is x minus 1. It's a difference of squares. Sorry, that looks like, yeah, that's a plus 1 right there. Does that make sense? You could FOIL the bottom. Usually my rule of thumb is if it adds something helpful, you could try it. But I think I know in my head, if I FOIL it, is it going to help anything else cancel? No. So you could probably leave it there. I wouldn't mark it wrong, though, if you call it like negative x minus 1. But like by FOILing it out, was something else able to cancel? No. So then just leave it. Don't do work that's not purposeful. So you know how, let me say this and we'll take our break. When we do square roots, our whole goal is to square. Does that make sense? But square at the right time. When we deal with fractions, our whole goal is to cancel stuff, top and bottom. But we have to do it at like the right moments as well. I can't just go willy-nilly saying, hey, look, there's an x right here. There's an x right here. Hey, cancel. That's not the right moment. Does that make sense? As soon as you cannot find anything else that can cancel top and bottom, you're done. Okay. When you guys come back from a break, my goal then going forward is we're going to deal with how to multiply and eventually how to divide. All right, and we'll see how far we get. So, go take a 5-minute break. Wait, so here's our goal. I want to show you guys now how to multiply fractions, which I think you guys probably learned at some point in your life. Multiplying fractions is actually fairly straightforward. You take the numerators and multiply them. You take the denominators and you multiply them. That's it. So like here's an example slide I found. If I give you 2 over 5 and 3 over 4, 2 times 3 is 6 and 5 times 4 is 20. That's it. So if you like my Johnny Depp Pirates of the Caribbean analogy, it's the same stuff. We're going to try to cancel stuff, but wait for the opportune moment. The opportune moment sometimes is right away. Before we even try to multiply things, it may not hurt to try to factor what we can. So for example, right here on the bottom, see this binomial right here? I can factor that. So let's factor it. So you can factor out 3x and it leaves you with x plus 2. Is it okay if I don't use an x but I use a dot, just so I don't somehow screw that up? Yeah. And then on the top, what can I factor out of this guy? Yeah, 4x squared, which leaves you with x plus 2. Now is an opportune moment. Like for example here, see how I have 3 x's kicking around right there? And I have just a single little x on the bottom right there? I'm going to try to use colors to help keep this straight. I know you guys probably can't, but that x will go if that guy pops down to a 2. That makes sense?
Shouldn't that 4x be squared?
Oh, thank you. You're right. I made a mistake. See, I make mistakes too, guys. Okay, 12 and 3, also useful. 12 and 3 can become 4 and I guess gone. If you wanted to. Try that again here.
Oh, yeah.
You have 12 and 3. 12 and 3 can be 4 and 1, I guess. Right? Like divide everything by 3, so that's a 4. I won't even write the 1 there. However, I made this one on purpose to illustrate a point. You have a binomial as part of the first denominator, and you have the same binomial as part of the second numerator. We do this in chemistry already, where if you have something on the bottom of a fraction and something on the top of a subsequent fraction being multiplied, these can be canceled as well, actually. So like I said, wait for the opportune moment. Originally, maybe it wasn't a good idea, but actually you can kind of like cancel this one with that one as well. Okay, what's left? Put it all together now. You've got a 4 here and a 4 there. Multiply them though. So 16. You've got x squared right here and x squared right there. So x to the 4. And there's only a 5 left on the bottom. Is there anything left you can cancel that you can think of? 16 and 5 are not divisible by each other. You don't have any other binomials. Now we're done. So again, wait for the opportune moment. Factor, find stuff that's the same on the top and the bottom, and cancel. So I'm repeating myself a lot. How do you deal with square roots? You square. You just make sure you square at the right time. How do you deal with fractions? You cancel. You just make sure you wait till the right time, and then you cancel. Let's try some more. How about this one? Can I cancel yet? Well, no. But if I do some of my factoring skills, and maybe you guys can see kind of why this all fits together. We started off our year learning how to factor because that skill is still useful in this one. So, I'm going to do this a little faster if that's okay. You're looking for numbers that add to give -1 and times to give -12. And that's a 4 and a 3. With a -4 and a +3. I'm just talking about this guy right here in red.
What's that second one?
Sorry, x plus 3. X squared minus 9. Difference of squares. So x plus 3, x minus 3. I'm not going to cancel it just yet, but I see something that probably will. Next color. I'm just trying to color coordinate it. This guy right here is probably also factorable. Numbers that add to give -4, times to give 3. -1 and -3 will do it. Are you guys okay with me going that fast on the factoring? Okay. And then on the bottom, this last guy right here, I actually can't factor a ton, but they both have an x. So I can remove the x and make it x. Ew, that's not right. X minus 4. That was this guy here. You have 1 bullet in your gun. Now is the opportune time. Cancel away. That guy and that guy, they can go. That guy and that guy, they can go. This one and that one, they can go. Yeah. If it's on the top and if it's on the bottom, they can cancel. What's left? Can you do this? Not the opportune time anymore. One's a binomial, one's a monomial, that doesn't count. So don't try to take it to -1. Oop, I went too far. It's x minus 1 over x. That's it. There is nothing more that you can cancel. One more time. How do you deal with square roots? You square them. You just gotta wait for the right time. How do you deal with fractions? You cancel stuff. But make sure you do it at the right moment as well. Algebraically manipulate stuff to the right time. Okay, so let's make it more of a challenge. Okay. I would not ask you guys in Dash 2 to probably solve something like this, by the way. But Dash 1, you get the challenge. So, what can you factor? Well, this little guy right here you can factor. What does this little bit right here factor to? Okay, -5 and +1. That's a +1, by the way. Okay. I just showed you guys this a little while ago. What happens if something is to the power of -1? Do you remember what it was? It means that it's over top of that. It's on the bottom of the fraction. This x minus 5 is actually supposed to be on the bottom of the fraction. That's what this -1 means, is that it's supposed to be down there. It's just another way of writing it. That's all. Don't forget that there's this x plus 3 still sitting here as well. So that x plus 3 is right there still. But the x minus 5 came down. All right. What about x squared minus 1? You can factor this guy, right? It's the difference of squares of x plus 1 and x minus 1. What does a minus 2 up here mean then? I want to take a stab at it. Yes, you got it. Yeah, that's all it means. It's just a notation issue. So it means that x plus 1 comes on the bottom, but it's down there twice. Now is the opportune moment. Cancel away. So here's an x plus 1 that can go with that one. There's an x plus 1 that can go with that one. Here's an x plus 5 that can go with that one. What's left? You good? So what's left? You have an x minus 1 on the top, an x plus 3 on the bottom. Oh, and sorry, thank you. Some of you guys are giving me funny looks for a really good reason. And an x minus 2. Thank you. Okay, someone might ask the question, should I FOIL the bottom? My general rule of thumb, only do something mathematically that's going to be useful. Useful in this case is causing us to cancel. If I FOILed that out, is it going to help us cancel something? No. So don't. I mean, you can. I won't mark it wrong, but it's not helpful. Yeah. Yeah, so like if this guy was x minus 1 and this guy is x plus 1, they are not the same. They have to be literally the exact same binomial. Here's just a little chart reminding you of some exponent rules. So if you ever get a 1/2 exponent, it means it's a square root. A 1/3 means a cubed root, a 1/4 means a fourth root. Similarly, if you get a minus 1 or a minus 2 or a minus 3, it just means it goes on the bottom of a fraction. So they actually do have some similarities. Exponents can mean, if they're fractions, square roots, or if they're negatives, negatives actually means fractions, I guess. Does that work? Okay, now for the fun one. Now let's divide. Okay, dividing works kind of similarly, except maybe you've heard this trick before. When you actually divide a fraction, you multiply by the reciprocal. You guys ever heard that phrasing before? Okay, let me see if I can find a slide here that talks about it before we do that. In this example right here, 4 divided by 2 is possible. However, 5 divided by 3 is not possible. So there's a trick that you play. Rather than dividing, you multiply, but the second fraction, you flip. You guys ever seen that before? Yeah. Okay, good. And then basically, rather than dividing, you're multiplying.
Do we have to flip the exponents too then? Like if it's a negative on the bottom, it'd be a positive on the top?
If the exponent was a negative on the bottom, then it would actually, yes, like you would flip that too. But we don't have that in this case. Like this 2 right here, don't flip that 2 though. That's not that is what you were asking though.
I meant like the negative 18.
The negative 18, we don't flip that. Here, let me just try this one. Give me a sec, would you? Let me try this. What this means to do is take x minus 5 over 3x squared minus 9, and we're going to times it.
Mrs. Fisher, you have a call on line 1. Mrs. Fisher, you have a call on line 1.
And we just take that second fraction, and we flip it like that. Thank you. So all you do is you take this little guy right here, and you just invert it. At this point here, it's exactly what we just did. So dividing, honestly, is not that treacherous. Take the second fraction, flip it. Keep going. So, wait for the opportune moment. There's a 5 here, there's a 5 here, but those don't cancel. The opportune moment is once we've factored everything. So x minus 5 can't factor. What about down here, though? Yeah, you can pull out a 3x. It leaves you with x minus 3. What about this guy up top here? (6x squared minus 18). Just 6, actually. Yeah, you can take out a 6. What will it leave you with? X squared minus 3 all over 5. Now is the opportune moment. Okay.
Marley Duncan, can you please come to the office? Marley Duncan, please come to the office.
I can't guarantee that it'll always be like, hey, look, everything cancels. And I've picked this one on purpose to make a few points. Here's an x minus 3. Here's an x squared minus 3. Can they cancel? Here's an x minus 5. There's a 5. Can those cancel? No. There's only one thing that cancels. Anyone pick out what it is? Nope. Yeah, this 6 right here is a monomial as a number. And this 3x right here is also a monomial as a number. This x and this x can't cancel because this one's part of a binomial and this one's part of a monomial. Makes sense. So the only thing that can cancel is this 3 right here and that 6 right there. No, sorry, reduce the 6 down to a 2. So when we're done, this is not actually that reduced at all. I mean, it is. It's done. We have an x minus 5. We have an x squared minus 3. And we also have a 2. Typical convention is you put the 2 out front. But you could actually put it last if you wanted. And then on the bottom, you have an x minus 3. You have an x. And you have a 5. And typical convention is to put those in front as well. You don't have to put them in front, but that's typically what we do. And that's it. Like, that is simplified. If you wanted to, you could FOIL all this crap, but why? How will that help you? Yeah.
Where did the x come from?
Sorry, this x right here. That makes sense.
How come the 2 isn't part of the x minus 5 and not part of the x?
Okay, so order does not matter. You could have written this 2 at the end if you like. You could have written this 2 in the middle. I just wanted to let you guys know, convention typically is that you put all of your coefficients first. I think the best reason for that is that you don't accidentally somehow slip them inside of a bracket. Because that would be the worst, right? If you accidentally had a 2 right here, and you said it was x minus 52. You see how that is a likely way you could screw up? So, like, not that you can't do that, but I just recommend throw your numbers up front. Okay, those are the skills you need. Let's hop to a really hard question like this one here. Let's try to solve the last one I got. So I've shown you all the skills you need. So if I'm asking you to divide things and work with fractions, we're looking to cancel. But don't cancel until we're ready. We're not ready. So what should I do? For sure, let's flip the second one.
Do you always flip the second one, or can you flip the first one?
No, you always flip the second one. Good question. Yeah, by convention, and I can give you a proof for why that works if you wanted. But most of the times we just tell kids, here's how you do it dividing. You flip the second one. So while we're at it, could I do a couple of steps at once?
You can add the x minus 7 to the bottom.
Yeah, you could throw that x minus 7 to the bottom. And I'm also going to try to FOIL factor everything while I'm at it too. If you want to do this in steps, you can, but I'm going to try to do it all in one big piece. So this guy right here I'm going to do in purple. It probably can be FOILed or factored. Minus 7 and plus 1 probably. This x plus 7 will have to stay there. And Michael just pointed out this x minus 7 that's on the top is a minus 1. Now it comes to the bottom. Does that work? I already see something that I can cancel, but I'm just going to hold off just for a second. Finish the rest, right? Then this guy right here, we're going to flip. And again, I'm also actually going to try to factor if I can. So I'll just use colors to try to keep it straight. This guy right here that was on the top is going on the bottom. Which one are you looking at?
The second one.
This is x plus 1.
Okay.
Sorry, I need to be a little bit better. I will do my best. All right. This guy up here, we need numbers that add to 8 times to 7. 7 and 1, yeah. So that'll be x plus 1, x plus 7. There, I'll take more time to write it out nicely. And then I'll use black for this guy. This guy here is on the bottom. It's going on the top. What can I factor out of that? Anything in common there? That's it. That's all we got. That leaves you x plus 7. Now is the opportune moment. Cancel! 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 Ta-da! It's actually kind of satisfying. That makes sense? Okay. That's the skills. Today we're going to work on multiply and divide. Tomorrow I'm going to focus on add and subtract. I already mentioned add and subtract. Add and subtract sucks because you have to have common denominators. And then you keep doing what you always do. You put them together with common denominators, and then you still try to cancel stuff. But again, I'll say this a lot. I think this fits. Especially if you've seen the movie. You gotta wait for the right moment before you try canceling. If you do it the wrong moment, it's not working. Sorry. Okay, I do have one last slide. I just want to point something out. In a future unit, when we talk about functions, you might see in the textbook sometimes something called non-permissible values. If you ever do textbook questions, ignore that idea. I will cover it later, I promise. I want to do it in like pieces, so I don't want to go too overwhelming at this point. Okay, so here are some things that you could work on. Here's the running list. We are probably up to like the page 327 stuff. I believe on my website, I think I should have a worksheet on there on rational expressions if you want practice. But if you're looking for textbook questions, try 1, 2, 7, and 8. And I'll try to find something for you guys. I might need to photocopy something. One last thought. Okay, well done. You can hold on to it. I don't need it. I'll record it later. I did give you guys an assignment last week on Friday, right? Okay. My hope was to have that be due this Friday, but I'm feeling like that might not be reasonable. So start working on that, and later in the week we'll try to figure out when an appropriate due date is. But I'm thinking Friday might not be enough time. So, and that's fine. We'll figure a new due date out. Yeah, I might need to print it though, but yeah. Let me do it. It's faster from here.